Hi, my name is Luka, and today I will present to you my master's thesis in cartography, constructing and evaluating a building facade color map for urban navigation. So here's a street in Vienna, and here's how it looks like on my phone. And as you can see, the visual characteristics of the buildings are not represented on this map, even though it takes about 50% of the image. So how to represent building facade colors on a map, and is it actually useful? Well, we used to represent buildings with quite a lot of details on all the maps, and nowadays we can still find that sometimes, but only for a few buildings that are represented as visual landmarks. But it's never done in a systematic way. It was shown that landmarks is extremely important for orientation, of course, and that some special buildings can be used as navigation clues. So how to represent building facade colors on a map? Well, I adopted a very simple approach where every building is assigned to only one color. And I picked all my colors on Google Street View. But as you can see already here, we have some kind of bias because I could have chosen either the light side or the shadow side, and some buildings have multiple colors. That's why I asked 6 other participants to do the same task, and I compared their selection with mine, and we ended up having quite similar results. That's why I continued that way. So here's a sample of the final map. And you have to think that this could be implemented with other layers of information, and it can start feeling quite overwhelming. So as an attempt to reduce cognitive load, I wanted to reduce the amount of information, so to reduce the colors, while keeping the important colors on the map, so the colors that were standing out and that could be used as visual landmarks. And that's what I called color generalization. So how does it work? Well, I worked in the CIE lab color space, which is perception friendly, and I used the proximity formula. So I project all my colors in this color space here on the left side, and then I group them together according to their distances. And once I have these groups, I take the average color of each group, and then I project them back on the buildings of the map. But there are many different clustering methods that exist. And I compared only k-means and mean shift. So k-means in blue here tends to create some groups of similar sizes, while mean shift creates one group with many colors and many groups with only few colors. And this is very interesting here because it means that the colors that are far apart from each other are actually displayed again on the map and not averaged with the rest of the colors. So in the end, I ended up picking min shift, and here's what it looks like. On the left side, we have min shift, and as you can see, this sharp blue colors is still standing out, while k-means on the right side tends to flatten this color diversity, and we don't have these salient colors that are standing out, so we don't have any visual clues anymore. So second part now, is it actually useful? Well, I created an online user testing platform to evaluate this. On the right side, we have Google Street View that was used as a virtual environment. And on the left side, we have Mapbox Studio, in which I implemented my map. And I asked the users to go from point A to point B while following this purple path. So the user either got a gray map or the color map, and then it was switched. And then there was a final questionnaire. I used 3 metrics here to evaluate the user's behavior. So the arrival at destination. So I wanted to check whether the user actually arrived at the final destination, the observational behavior of the user, how much the user was looking around while following the path, and the inside-outside ratio, which scores how much the user actually stayed on the path during the task. And these three metrics didn't show much differences between the user between the two groups. Nevertheless, we have some interesting outputs with the final questionnaires, especially about the user confidence. And users tend to feel more confident when using the color map than when using the gray map. So that's it for me. I just want to underline the 2 main aspects of the thesis here. First, the color generalization algorithm that I implemented on a map, and I changed the colors dynamically according to the zoom level. And then this online user testing platform that can be shared easily online and that acts as a virtual environment, and it can be modified maybe also for other studies. Thank you very much for your attention.